Hello students, today's topic is about Introduction to Dental Materials. In the previous lecture by Dr. Kumar, he has already discussed about history, what are the requirements, and about a little bit about the classification of the dental materials. Today we'll go into a little bit in depth into classification and basic properties of dental materials. As you all know, dental materials can be classified into preventive dental materials, restorative dental materials, and auxiliary dental materials. Restorative dental materials again are classified into direct restorative materials and indirect restorative materials. Direct restorative materials being like GIC, which are going to be filled directly into the patient's mouth. Whereas indirect restorative means like your crown or a fixed partial denture. These comes under indirect restorative materials, that is, they are made outside and then placed into the patient's mouth. Preventive dental materials generally help in prevention of a disease, especially in our terms, caries or a gingival problem or abrasion or anything of those kinds. Auxiliary dental materials are those that aid in restorative dental materials like impression materials, rotary instruments, etc. Okay. So this is the picture showing various preventive dental materials. The first picture is showing about the pit and fissure sealants. Second one is a fluoride varnish, and the last one is phosphor mouthwash, which helps in remineralization. Restorative dental materials, I told you, again they are direct restorative materials like JAC, composites, and amalgam, silver amalgam, etc. Or indirect restorative materials like metallic crowns or ceramic crowns, bridges, etc. Auxiliary dental materials being impression materials, waxes, investments, gypsum products, all these things comes under auxiliary dental materials. Fine. Any dental product that comes into market has to be standardized. So there should be some governing body that comes with specifications for any such given material. Likewise, in for dental materials, ADA under American National Standard Institute, ANSI, helps to formulate specifications for dental materials, instruments, and equipment. Similarly, there are certain international organizations like ISO, which stands for International Organization for Standardization, FDA, Federation Dentaire International. These bodies also help in standardizing the dental products all over the world. There are certain other products like Committee European Denormalization, Commonwealth Bureau of Dental Standards, etc. So these federations help in standardization of the dental materials, instruments, and equipment. So they give certain specifications for each material. That's how this ADA specification numbers came into existence. So since this is being introduction, I am not going to discuss in depth about all the specifications. Say for example, ADA specification number 1 stands for alloy for dental amalgam. ADA specification number 19 stands for elastomeric impression materials. ADA specification number 25 for your dental gypsum products. ADA specification number 119 stands for manual toothbrushes. I told you, no, along with the materials, even the equipment have to be standardized by or follow the ADA specification rules. Even motorized toothbrushes, they fall under 120 of ADA specification number. So likewise, each and every material has got a number under which there are specific guidelines which it has to meet up to. Coming to basic properties of dental materials. In this, you will be learning about structure of matter and principles of adhesion, physical properties of dental materials, mechanical properties of dental materials, solidification and microstructure of metals, equilibrium phase in cast alloys, dental polymers, and biocompatibility of alloys. So all this, you should be thorough with all these basic topics. Then only you will understand better about each and every product, dental product you are going to learn later. So coming to structure of matter and principles of adhesion. Matter is what? It's everywhere. It consists of, basic component of matter is atom. So this matter exists as, it can exist as solid, liquid, gas. This solid, liquid and gas, they can change from one form to other based on the energy that is being applied over the matter. These atoms existing in the matter are bound by interatomic primary bonds, which are ionic, covalent, or metallic. There are also secondary atomic bonds, which are also called as van der Waals forces. In structure of matter, you should also understand about interatomic bond distance and bonding energy, and about thermal energy. Thermal energy is kinetic energy of the atoms or molecules at given temperature. So these atoms tend to move or vibrate. Their energy at a given temperature is called as thermal energy. So this is a pictorial depiction of state of matter. It can be either solid, liquid, or gas. This liquid can be converted into gas by evaporization. Gas can be converted back into liquid by condensation. Likewise, gas can be converted to solid by a process called as deposition. In the opposite manner, by sublimation, solid can directly convert into gas. Solid can also be converted to liquid by melting. Again, the liquid can be converted to solid by freezing. So these are the three states of matter. It can be converted into one form or the other. Coming to bonding, as I told you, we have ionic bond, covalent bond, metallic bond, and van der Waals bond. Ionic bond, classic example is sodium chloride. Here what happens? Sodium and chloride there will be a transfer of electron from one element to the other, thereby leading to the bond. This is called as ionic bond. In covalent bond, if you can see in the picture, there is a sharing of electron. So one element will share one electron, the other element will share one electron. There is a common sharing of the electrons happening. So that is why it is called as covalent bond. For example is water, H2O. Metallic bond, this is again can be thought of as if cloud of positively charged ions. Cloud of positively charged ions immersed in cloud of valence electrons. So there will be electrons, all positive charged ions will be sitting at one point and electrons will be moving around. So this helps in transfer, free movement of electrons. That's why your thermal conductivity or electrical conductivity can happen in metals. And finally, van der Waals bond is a weak polar bond between the two atoms. That is due to a weak electrical force. So this is about bonding. So all these things will be discussed in detail. Coming to structure of matter and principles of adhesion. The matter exists as a solid form or in a crystalline structure also. This crystalline structure is nothing but arrangement of atoms in space. So crystalline forms could be of 14 possible types. This is formed by orderly arrangement of atoms. I will give you the picture for this also. Non-crystalline solids is due to disorderly arrangement of atoms. Example is waxes. Then you will also be learning about diffusion. That is diffusion of atoms or molecules in gas, liquid as well as in solid state. This happens based on the temperature. As you can see in the first picture above, a crystalline structure with an orderly arrangement of atoms, whereas an amorphous structure, disorderly arrangement of atoms. So this crystal lattice could be, I told you, could be of 14 types. Here is an example here, body-centered cubic lattice. This is face-centered cubic lattice, and this is hexagonal cubic lattice. So this is about cubic lattice structure. Coming to adhesion and bonding. One more main basic property is adhesion of materials, dental materials. So adhesion is nothing but attraction between unlike molecules, whereas cohesion is attraction between like molecules. And adhesive is a material that helps in adhesion of two surfaces. This adhesion is again dependent on surface tension, wetting and contact angle. So just understand these terminologies for now. Say for example, if you take a liquid and place it over a surface, if the wetting is good, surface the contact angle will be less, as shown in last picture. If there is less surface tension, there will be increased wetting and a decreased contact angle. This in turn helps in complete wetting of a surface. You can see here. If the contact angle is greater than 90 degrees, that means there is high surface tension and decreased wettability. So, for example, the hydrophobic agents will have higher contact angle. You understood? So, this is about adhesion, cohesion, and a adhesive. Another property is surface tension, wetting, and contact angle. Again, here in basic properties, you will be learning about physical and mechanical properties of dental materials. Physical properties like abrasion and abrasion resistance. This property is primarily determined based on hardness of the material. So for example, if you give a crown, metallic crown or a ceramic crown, which is much harder, if it is much harder than the opposing natural tooth, it tends to wear or abrade the opposing natural tooth. This is called as abrasion. You will also be learning about various properties like viscosity, rheology of dental materials. Viscosity is resistance of a liquid to flow. Rheology is study of flow characteristics of materials. Study of flow characteristics of materials. So the materials could be Newtonian, pseudoplastic, dilatant, dilatant and thixotropic. So what is the difference here? Newtonian means stress, shear stress will be proportional to strain in this type of liquids. Pseudoplastic means as you give more shear stress, the liquid will become more flowable. Dilatant means as you give more stress, shear stress, the material will become thicker. It will not flow at all. The flow will automatically come down. And finally, thixotropic materials. These materials exhibit a different viscosity after it is deformed. Example being zinc oxide eugenol cements. So like this, each liquid has various flow properties and these can be discussed under rheology. We'll also be discussing or learning about structural and stress relaxation. This happens especially in terms of waxes. And also you will be learning about creep, which is a time dependent plastic deformation. Creep you will be learning in relevance to silver amalgam material, and flow properties of various materials. This is a picture demonstrating various viscosities. One thinner viscosity is easily flowing, whereas the higher viscosity one is not flowing as easily as the thinner one. Then about color and color perception. See, there are, for any color, there are three components, main components, that is hue, chroma, and value. What is a hue? Hue is the basic color of a object. Say for example green, yellow, pink, blue, whatever it is. Then chroma. Chroma is amount of color per unit area. See, you can see in the picture, less green to more green. Amount of color per unit area. So that is called as chroma. Then you have value. Lightness or darkness of a given color. It is called as value. Then you have other component, that is translucency. The ability of a material to partially allow the light to pass through it. These are the basic properties of color. And then the color is very important to be determined in dentistry, because you are going to do shade selection or color selection for each individual patient. So you should learn how to identify the specific color for a specific patient, that is color perception. We'll also be learning about thermophysical properties such as thermal conductivity, thermal diffusivity, coefficient of thermal expansion, and in detail about tarnish and corrosion, causes for tarnish and corrosion, classification of corrosion, electrochemical corrosion, and protection against corrosion. It's a frequently asked topic in your exams, tarnish and corrosion. So in the first picture, you can see a circuit has formed here between the two dissimilar restorations. If there are two dissimilar restorations facing each other and saliva acting as an electrolyte, there is a circuit formed leading to galvanic corrosion or galvanic shock. This is second picture is showing an amalgam filling which has led to tarnish around the filling. Coming to mechanical properties of dental materials. In this you will be learning about stresses and strain, under which you will be learning about tensile stress, compressive stress, and shear stress. Mechanical properties based on elastic deformation. Under this you will be learning about modulus of elasticity, flexibility, resilience, and Poisson's ratio. And in strength properties you will be learning about proportional limit, elastic limit, yield strength, permanent deformation, flexural strength, and impact strength. This is a pictorial representation here. Stress is force per unit area, and strain is change in shape per original shape, or change in length per original length. That is called as strain. In the second picture down below, you can see various types of stresses. First one is based, this is all depending on the direction in which the load is applied. First one is compressive stress. That is in two opposite directions. Second one is tension, that is tensile stress, pulled on both sides in equal in opposite direction. Third one is shear stress. Fourth one is torsion. And finally the last one is bending. These are various types of stresses that can be applied to an object. We'll also learn about solidification and microstructure of metals. Metal basically consists of an element or an alloy. And an alloy consists of two or more elements of which at least one is metal. Remember, at least one is metal. Then it is called as alloy. What alloys are used in dentistry? Alloys with noble metals, alloys without noble metals. Alloys with noble metals are also again classified as precious and semi-precious. In precious, it could be gold-based alloys or palladium-based alloys. In semi-precious, again, we have low gold alloys or silver-based alloys. Non-precious, also called as base metal alloys. Here you can find cobalt chromium, titanium, nickel chromium, etc. So these are the broad classification of alloys used in dental practice. Applications of these metals and alloys, you can see they are used for inlay, onlay, fixed partial denture, implants, and even cast partial dentures. Okay, these are various applications of these metals used in dentistry. Then you will also learn about dental polymers, its application in dentistry, how they are classified, what are its requirements and its properties, chemistry of polymerization and copolymerization, and its applications. So dental polymers, they are used in various applications, like for example in fixed prosthodontics they are used for as polymers can be used as cements, impression trays, impression materials, temporary crowns. In removable prosthodontics they are used for impression trays, impression materials, denture bases, and denture teeth. For orthodontic applications they are used as retainers. In maxillofacial prosthodontics, used in fabrication of prostheses. For prevention, these polymers in various forms are used as sealants and also for mouth guards. In operative dentistry, used as composites, resin modified glass enemas, occlusal splints, and finally for laboratory applications include indexing resins and model materials. So there are wide variety of applications or uses of polymers in dentistry. Okay, see here you can see first picture is a special tray fabricated. Second picture you can see a flexible RPD that is being fabricated. Third one is a CD in patient's mouth, complete denture in patient's mouth. And finally, there is a removable partial denture where actually in this removable partial denture, one form wherein there is a metal framework. Here the metal framework, instead of metal framework, they are given a acrylic framework itself so that it becomes much more lighter. So these are various, there are many more applications as we had read before. And finally, biocompatibility of these dental materials. That is, what are the adverse effects from dental materials like toxicity, inflammation, allergy, and mutagenicity, etc. And you will learn about biological response in dental environment and measuring the biocompatibility of the materials. Usually this biocompatibility is done, tests are done in primary, secondary and usage tests. So this is about basic properties of dental materials. In the next section, we'll be discussing about various materials, dental materials and their applications. Various dental materials and their applications in dentistry. So this is what we are going to learn in next class. Thank you all.